Hi, welcome. In this video, we will solve problem jump game type 2 asked by companies like Amazon, Microsoft, Google and Uber. Hey, welcome back to one another video. Let's check out one more problem on greedy, that is jump game variation 2. We have already solved one variation jump game. Okay. So if you have not checked out, please check that video jump game one variation. Okay. So now in this question, this is exactly same the few variation here we have. That is, you are given a zero indexed array of integers, nums of length n. Basically, one array is given of nums of length n. And you are initially positioned at nums of 0, exactly same as the previous. We are at this position, right? 0 index. Okay. Each element nums of I represent the maximum length forward jump from that index. Again, same. So if 2 is there, that means the maximum jump that you can take, that is 2 here. Okay. If you are at nums of I, that means you can jump to nums I plus j. So basically it is saying that if your I is equals to 0, that means your jump will be I plus j, where j can be from 0 to 2. Okay, that means you can take either 0 jump, 1 jump or 2 jump, right? So here j will vary from 0 to nums of I. Okay, and I plus j always be less than n, right? So like if you have an I, if you and j, so it always be less than n. Okay, so moving forward, return the minimum number of jumps. Okay, so in the last question we were just calculating, is it possible to reach the end or not, right? But here we just need to tell that what are the minimum number of jumps. That means the test cases are generated such a way that you will always reach at the last index. Okay, so it is completely sure that you will reach to the last index, but you just need to tell how many jumps you will take to reach at the last index and tell me the minimum number of jumps. Okay, so if you are taking this example, okay, there are many ways possible to reach the last index, but the minimum number of jumps will be possible. That is, you will take first jump and then you will take 3-step jump, right? So total number of jumps are 2, 1 and 2. Similarly here you will take one jump here, 1-step jump and 3-step jump, and the total number of jumps will be 2. Okay, other ways to reach this end here will be, like if I say what is the other way, like if you take one jump here and if you take 2-step jump, so you will be here, and 1-step jump here, right? So there will be a one more way, that is a 3 jump total here. Like if you are taking one jump again and again, again and again, again and again, so the maximum number of jumps you will take to reach here, that is 4. The maximum number of jumps you will take to reach here, that will be 3. Okay, but we need to find the minimum number, that's why the answer is 2. Okay, so now let's understand this problem statement, how we can solve this problem statement. We will discuss it and we will come to some approach. Okay, so again we are at this position right here. Okay, so now let's see what are the possible ways to reach to this end, right? This is my end. So one way is taking 1-step jump again and again, right? So 4. Okay, one way can be that if I take 2-step jump, okay, and then if I take, then I will take 1-step jump and then I will take 1-step jump. That is also one way. Okay, one way can be that you are taking 1-step jump and then a 3-step jump, so you will be end here. Okay, so if I represent these like this, 2 3 1 1 4, okay, and so from here you are at this here position, right? 0 index. Okay, so you can either take 1-step jump or a 2-step jump, you will be here. Now from here you need to take again 1-step jump, that is the only possibility. Then again you will take 1-step jump and you will reach to the end. Okay, and suppose you choose this path. Okay, here you have taken like 1 step only. Now again there are 3 ways, either you can take 1 step, or you can take a 2-step, or you can take a 3-step. Okay, so if you are taking 1 step, then you will take 1 step to complete it, then again 1 step to complete it. Okay, if you are taking 2 step here, then you will take again 1 step to complete it, right? And if you are taking 3 step, then you will simply complete it, right? So if you check, there are different ways to cover it, right? One possible way is this way, right? One step, one step, one step, one step, right? One possible way is this one, and you are taking this one. Only two jumps, right? One way is this way, right? So there are different possible ways, okay? And from these ways, again, I am saying there are possible ways, and from these ways, we need to find the minimum number of ways. Number of ways. If you get some hunch, are you getting some intuition? It is, sounds like recursion, right? That there are different possible ways to reach a point, different possible paths to reach a point. Okay, and from that we need to find a minimum number of paths. Okay, so yes, we can solve it by recursion, simple recursion problem. So suppose you are at 0 comma 0 with jumps, right? So suppose this is represents your jump, this is represents your index. Okay, then you can either take one step jump or you can take two step jump, right? You have this one and two, right? Two possibilities. So if you are taking one step jump, you will be at index 1 with one jump. If you are taking two step jump, you will be at index 2 with the two jumps, sorry, one jump only. Now from here, when you are here, you have three possibilities, right? Either you can take one step, right? One, then two, and then three. Remember how I am getting this? By these number, right? Three numbers, right? The number value is three. Here the number value is two. Okay. So if I am taking the one step jump, I will be here at index 2 with the two jumps. I will be here at index 3 with two jumps. I will be at index 4 with three jumps. Sorry, two jumps. Okay. Similarly here, if I am at index 2, I have only one way. That is, I can take one jump. So I will be at index 3 with two jumps, right? One jump, then two jumps. Okay. Similarly, I can increase this one. This is also one possible way. That is, I can take only this way. That is one jump. So that will be having one jump. So that is represents for 1, 2, 3, 1, 1. Okay. Okay. So you can see here, this is one of the recursion, basic recursion, where you need to run these indexes till the index value, right? And we can solve it by recursion. So what will be the recursive code for it? Okay, if I go, so what I will do, I will simply write recursive solution. So suppose I have this one function with function index and jump. Okay, this is my function with index and jump, and where I will stop, what will be my base condition for it? Okay, when I will stop, like you can see, I am stopping here whenever my index value is getting greater than or equal to the n or n minus 1. I will simply stop it. I will simply return jumps, whatever the jumps available. Okay, jump, because I'm taking one jump. Okay, now what I need to do, I just need to run a loop, right? That will I stands from 1, because see, you are at already 0 comma 0, right? You will call this function from 0 comma 0 with 0 and 0 index. From here you will take the jumps, right? And how you will take the jumps? Basically, you will start from 1 to the array I, whatever the element is representing, right? So you will run till array I, right? So I is equals to 1 to array I, and once you started this, okay, basically you are not starting from this index. Basically this 1 stands for number of jumps, 1 2 3, right? So if the value is 2, so I will take either 1 and 2, right? I can be value of 1 and 2. If there is 3, so I can take 1 2 and 3, and from these values I will find the minimum number of paths, minimum number of jumps. So what I will take one minimum, and then will be method dot minimum of whatever the minimum is. So let's declare one minimum. Suppose minimum equals to minus infinity, and I will take my function. I will call one function, this function again with index plus 1 and jump. So that will be here, it not be index plus 1, it be index plus I. Okay, because I is changing, right? You will add 1 2 3, and that will contribute to your number of jumps. And if this is possible, right, if this is running, right, this is your for loop. After this, what you will do, you will simply return minimum, right, whatever the minimum is, you will return minimum. Instead of jump, I guess here you can also return minimum, whatever the minimum you were. Okay, so this not minimum, sorry, this is will be jump, because you will return jump and then you will in the last you will return minimum, so it will calculate the minimum number of jumps. Now if we are solving with this recursive function, this will be recursive code of it. Okay, and so what will be the time complexity of it? So these values can be anything, right? First of all, array is of size n, and the values inside it can be go to len, right? So like I am running from 1 2 3, this is can go up to n, right? So the time complexity, okay, the worst case, very worst case, can be big of n power n, right? N power n, that can be one worst case can be possible, right? And again space complexity, so space complexity will be big of n. What is this n big of n? We are not taking any extra space, but this is the recursion stack memory, right? So whatever the recursion stack will create, that will be the memory, the space that we have used. Okay, although that you can use dp here, right, dynamic programming, if you know the concept. Okay, you can use the concept of dp, so basically you can store the jumps, and if you store the jumps, so you can reduce the time complexity. The time complexity can be quadratic by simply storing dp values. Okay, and once if you are clear with dynamic programming, and once you stored it, then you can simply return the answer. Okay, so that is one possible way, approach one. Okay, but we are not going to solve this again, because the India won't be happy because of this solution, because again this is still comes in big of n square, even if you are applying for this dp solutions. Okay, so we need to come with some another approach, some efficient approach. So let's see how we can try a different approach. Okay, what is the intuition behind of a different approach? So let's talk about approach 2. Again, let's take the same example. We have 2 3 1 1 and 2, and it was 2, I guess 4, it won't matter, but let's see, 4 and 0 1 2 3 4. Okay, these are the indexes. Okay, so what we were doing here, when we were doing, we were calculating the number of possible paths, right? This is one path. Okay, this is one path possible from this position. Okay, this is one path possible. Okay, that was our intuition, and this is how we were solving at that time. Now how we can solve this? Is there any way? Do I really consider the path? Okay, because no matter, right, I am reaching to the last index, that is sure. Okay, but I want to know, like, what is the minimum path, right? Minimum number of jumps will be required. Okay, so I am more interested on that. So what we can do, we can find a range of it, right? The maximum range. I will be greedy on the range. Okay, okay, I am a greedy, like where I can get, how I can reach to the farthest point. Okay, what I will get the range, so I am greedy on the range, that where I am getting the range. So suppose you are at here. Okay, you are at this position. Okay, so now tell me, what is the range, the maximum range you can achieve? Okay, the farthest point you can achieve if you are at here. Okay, so the lowest point that you can achieve from this point is this, right? Like you can take a one jump, that is for sure. Okay, and the maximum that you can achieve, that can be this one. Okay, that is a two-step jump. So basically either you can take a one-step jump or a two-step jump. So can I say the maximum range from this you can achieve to this one? So can I say of this, what is the last number? This one is the last number, right, of this range. Okay, you can come to this last this number only by taking one jump. Okay, one jump. This is like, this is the minimum. Like minimum jump will be one to get this position. How I can say that? Because I am getting this in a range. I am getting this in a range. from 2 I can take a one step jump, okay, or a two step jump, so I can reach it, right, by a one jump. So either to reach this position, either I will take two jumps or one jump. But the minimum number will be one. Let's see, let's analyze again. Now for this range, okay, can you tell me what will be the next range? Okay, from this step, suppose I am at here, right, because I have reached here, this is the minimum, right? By minimum number of jumps I am can reach the farthest distance. Okay, now from here, what will be the maximum range that I can achieve? So the minimum can be this one, I will be at here by taking one step jump only. Okay, or from this range, the maximum I can reach, that is this point, by taking a three step jump from here. So if I am in this range, the maximum position that I can reach, that is this one, right? Either I can take a one step jump, or from here I can take a three step jump. Okay, so can I say to reach this position, to reach this range, to reach this stage, I will require one more jump here, one more jump here. So one jump will be here, one jump will be here. Total number of jumps will be two. So two jumps will be required to reach it. Okay. Again, let's understand with a big example so that this will clear our all confusions. Okay. So let's take a big array and let me write few entries. So we have 2, 1, 1. Let's suppose 3, 5. Okay. 1, 2, 2, 3, 1, 1. Okay, I am taking some numbers so that we can get a much more sense. Okay, so let's see, suppose this is, you are feeling this is the largest number, so if I am taking the highest jump, I will reach to the maximum point. Let's see, let's try. So 1, 2, 3, 4, 5. If you are 1, 2, 3, 4, 5, right, you will reach here, I guess. 1, 2, 3, 4, 5, yeah, here. Okay, now from here you will take one jump again, one jump again to reach it. How you can reach it from here, the if I take the minimum. Okay, so if you are taking two step jump here, and then one step will be required, and then one step. Okay, so what are the total number of jumps you are taking? One, 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 one. So total three, six jumps. Okay, but this is not the minimum jumps. Okay, so if you are thinking that I will take the maximum number jump, I will reach to the last, no, not sure. Okay, how you can reach it, let's see. So suppose if you are at 2, okay, and if you are taking a two step jump, okay, then you are taking a one step jump. From here you are taking a three step jump, so 1, 2, 3 here, and from here if you are taking a two step jump, from here you are taking a three step jump, so 1, 2, 3 will reach here. So how many jumps will be required here? 1, 1, 1, 1, 1. So now this is 5 jumps, and this is the minimum number of jumps. So if we are thinking that if you are at the maximum number, right, greater number, and you are jump from there, you will reach to the last point. No, it's not true. Okay, so for this I am taking this example. Okay, this is a again very good example, and this will clear all the doubts. So let's see how we can use our same range concepts here, how we can achieve the result 5. So let me remove this one. So again the same concept, I am at here. Let me write the indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I am at here. Okay, now again from here, what is the maximum range that I can achieve? Okay, range, again the minimum and the maximum. The minimum distance that I can achieve from here, that is this point, this point. The maximum range from here I can achieve, that is this point, right? Two step or either one step. So can I say I can get this as a range, right? Can I say that this is my lower point and this is my rightmost point of this range? Okay, now for this range, what is the maximum for this range, what is the range I can achieve? Again, range. That means the lowest point and the farthest point. So the lowest point will be this one only, right? New L1, I will say, because I will take a one step jump. Okay. And the farthest point will be also this one. R1 also will be this one. So the minimum, the range that I can achieve this, that is L1 and R1. Because either if you are taking one step from here, you will reach to this point only. If you are taking one step here, you will reach to this point only. Now this is the new range that is coming out. Now tell me from here, what is the range you will get? Again, the lowest point and the farthest point. So the lowest point will be this one only, that you will stand it here. I will say L2. Okay. But farthest point will be for this, that is a 3. So 1, 2 and 3. So you will add here, right? So this will be L2 and R2. Now for this range, what will be the next range that you can achieve? Okay. So I, for the lowest point will be this one, right? Simple L3. Okay. But the maximum point that I can achieve, that will be, I can, if I am taking 5, what it will be 1, 2, 3, 4, 5. Okay, here. And if I am taking 2, so from here it will be 1 and 2. Okay, so can I say that this is my farthest point? Okay, yeah, for this range, this will be the farthest point only. 1, 2, 3, 4, 5. Yes, even if you are taking 1, you are taking 2, then you will be at here. So that is the possibility only, right? So I will say R3. Now for this range, tell me what will be the minimum? So the minimum will be again the next step. Again, if you are taking the next step, so it will be L4. Okay. And if you are taking this 3, so it will simply reach to the last point, right? So can I say my R4 will be here? So how many jumps I am taking? How many range I have discovered? One range, two, three, four, 5, and that is the minimum number of jumps, right? So basically what we will do, we will count our ranges, we will count our range. Okay, we will find the range, then we will find again next range, again next range, and then we will count the number of ranges. Okay, and how we will get the ranges? Basically the minimum point L and the maximum point, that is R. So this is how we will solve this problem. So how we can solve this problem? So let me write the pseudo code of it. Okay, so let me put it this here. Okay, and what will be the pseudocode? So I will take one L pointer that is starting from 0, R pointer 0, and count for these, counting all the ranges. Okay, and where I will stop, when I will stop, when I will stop, whenever can I say my R pointer, whenever my R pointer reaches to the last element. Okay, so can I say my while condition will run only when it is less than nums dot length -1, right? So it will run till that position only. Now what I will do, I will create one variable that is range that is starting from 0. Okay, and I will run one for loop that will start from I equals to L. Again, see, I will test everything, right? I will test this number of this range, like how I will get the maximum range. Okay, then I will, like, in this range also I will test this one 5 1 2. So I will test all the numbers. Okay, I will be less than equals to R and I plus plus, and then what I will do, I will simply update my range. So I will get different ranges, right? Like if I am printing 5, I will get the range, I will get the range. So that will be my range again, the point, farthest point, you can say. Okay, I will simply put method dot max because I will find the max of it. I will say I plus nums of I. Okay, and I will find maximum range. Okay, now what will be my L? You can see our new L is always L2 is R1 plus 1, our L3 is R2 plus 1. Okay, so my L will always be R plus 1, whatever the previous R. Okay, and what will be my r will be always maximum range. Okay, so whatever the range that I am getting, sorry, not the range, basically I have created one range variable. So this range, so r will be always the range because range is the last point. Okay, you can also say this as a last point. Okay, last point that you are meeting, and you can simply count as well, count plus plus. So in the last we will return count, and this will be the solution. So what will the time complexity of this approach? So you might be thinking that this is one while loop and this is one for loop, so the total time complexity will be big O of n square, but no, because this is for just a checkpoint that your r should not be go beyond the sum of like array's length. Okay, so this is a simple checkpoint, validate point, that r should not go beyond of it. Okay, basically you are moving from L to R only. So you are moving from this range, right? You are moving here to here. Then you are moving here to here. You are moving here to here. So if I say that you are moving only n times, strictly n times only, what are the number of elements available? Okay, because you are calculating the maximum number. How? I plus nums of I. So the time complexity of this approach will be big O of n only. Okay, and any space complexity that you are taking, no space, so the space complexity will be one big O of 1, and this will be one of the solution that you can apply. Okay, so yes, here the time complexity is big O of n, and this is comes under greedy. Why greedy? Because you are not focusing on the different paths. Okay, again, many paths possible, many paths possible, but you are not focusing on the possible paths. You are focusing on the range, the next range. What is the next range? That means you are focusing on the minimum path, minimum point, and the maximum point. Okay, and you are simply counting number of ranges. Okay, so this is one approach that you can try and you will get the answer. So in the next video I will simply write the complete code of it. Okay, we'll run it, and in the next video we'll show you the dry run.